The sun is dying. Not today. Not in your lifetime or your children's or 1,000 generations after that. But it is dying. Right now, at this exact moment, the sun is consuming itself, burning through 600 million tons of hydrogen every single second, converting it to helium, to heat, to the light hitting your skin. It has been doing this for 4.6 billion years, and it has enough fuel left for roughly 5 billion more. That sounds like forever. It isn't. In cosmic terms, our sun is middle-aged, a little past its prime, and like all stars of its type, it has a fixed, unavoidable ending written into its physics from the moment it formed. In this video, we're going to follow the sun all the way to that ending, through its violent death throes, past the destruction of Earth and into the strange, quiet object it will leave behind. Something that will still be drifting through the universe long after every other star has gone dark. The question isn't just how the sun dies, it's what it takes with it when it does. Let's start with what's keeping the sun alive right now, because it's a balancing act that has held steady for 4.6 billion years and cannot hold forever. Deep inside the sun's core, hydrogen atoms are being crushed together under almost incomprehensible pressure and heat, 15 million degrees Celsius, and fusing into helium. That fusion releases energy. That energy creates an outward pressure. And that outward pressure is the only thing preventing the sun's own gravity from collapsing it into nothing. It's a standoff. Gravity pulling in, fusion pushing out. Perfect equilibrium. But here's the problem. Every second that balance is maintained, the fuel supply shrinks. The sun is spending down a savings account that cannot be refilled. And when the hydrogen in the core runs low, the equilibrium breaks. That is when things get strange. About 5 billion years from now, the hydrogen in the sun's core will be exhausted. Fusion will stutter. The outward pressure will drop. Gravity will win, briefly, compressing the core further, heating it back up. That heat will reignite fusion, but now in a shell surrounding the dead core rather than at the center. And that changes everything. The extra energy pushes outward into the sun's outer layers. They expand, slowly at first, then dramatically. The sun will begin to swell into what astronomers call a red giant. It will grow and keep growing, eventually reaching a size hundreds of times larger than it is today. Mercury will be swallowed. Venus will be swallowed. And Earth, depending on which models you trust, will either be swallowed whole or will survive just barely, scorched beyond recognition. Its oceans boiled away long before the sun even reaches its maximum size. The expansion will take hundreds of millions of years, but life on Earth will end far sooner. As the sun slowly brightens over the next billion years, temperatures will rise enough to evaporate the oceans. The planet will become something like Venus is today, a pressure-cooked, acid-laced rock beneath a runaway greenhouse sky. This is not a disaster that arrives suddenly. It is a slow erasure. But the red giant phase is not the end. It is the setup. When the sun expands, it will also begin shedding its outer layers into space. Enormous clouds of gas and dust blown off by intense solar winds. Simultaneously, in the core, temperatures will eventually climb high enough to begin fusing helium into carbon and oxygen. The sun will flash through that fuel far faster than it burned through hydrogen. The core will pulse. In what astronomers call thermal pulses, the sun will expand and contract in waves, growing increasingly unstable over tens of thousands of years. Each pulse will throw more material into space, building a beautiful glowing shell of expelled gas around the dying star, a planetary nebula. Luminous rings and filaments lit up by the radiation still streaming from the core. There are thousands of these objects visible across our galaxy, each one the funeral shroud of a star like ours. From a distance, the death of our sun will be one of the most beautiful events our galaxy has ever produced. No one will be there to see it. And then, silence. When the outer layers have dispersed and the last of the helium fuel is spent, what remains is the core itself. Dense, small, hot, a ball of carbon and oxygen roughly the size of Earth, but containing roughly half the mass of the entire sun. Astronomers call this a white dwarf. It produces no new energy. It generates no fusion. It is simply heat, left over from 10 billion years of burning, slowly radiating into the surrounding darkness. A white dwarf cools across unimaginable timescales, tens of billions of years, hundreds of billions. Eventually, in a future so remote that it dwarfs everything that has come before, it will cool to the point where it no longer glows. It will become what physicists call a black dwarf. Cold, dark, crystallized remnant of a star that once warmed an entire solar system. Here's what makes that almost impossible to process. The universe is only 13.8 billion years old. White dwarfs cool on timescales of trillions of years. No black dwarf has ever existed yet. Not one. The universe is not old enough. Every black dwarf that will ever exist is still in the future. The white dwarf left behind by our sun will drift through the Milky Way for longer than the current age of the universe. It will outlast most other stars. It will still be there when the Milky Way merges with Andromeda. It will still be there when the last red dwarfs flicker out, billions of years from now. In a very real sense, the sun does not simply die. It changes form. It becomes something quieter, something patient. A cold crystal of carbon and oxygen carrying no memory of the worlds that once orbited it. Carl Sagan once said that we are made of star stuff. He meant it literally. The carbon in your body, the oxygen in your lungs, the iron in your blood. All of it was forged inside stars that lived and died before the sun was born. Our sun will do the same. When it sheds its outer layers in that final red giant phase, it will seed space with carbon and oxygen, raw material for future planets, future chemistry, future life. The sun's death is not a conclusion. It is a contribution. We are here because a star we will never know gave everything it had and scattered itself across the galaxy. Our sun will do that for someone else, or something else, or nothing at all, in a universe so old and empty that the very concept of an observer no longer applies. Either way, it gives. That's what stars do. If this made you think, a like or subscribe keeps this channel alive, which, unlike the sun, I intend to do for a while yet. See you next time.